Percent change expresses an amount of change as a percent of an original amount. So everything here is based off your original amount. So we need to be able to kind of recognize that through our problems. And it will be should be a relatively easy thing to see what the original amount was. Okay. We got two bullets there. It says the places that you guys see this most commonly is in retail. Okay. When you go to a store and you buy shoes that are 30% off. When you you go to a car dealership. So understand how car dealerships work. Okay. This is every business that sells a good does this. If I'm Reineke Ford, okay, and I want to sell trucks, Ford just doesn't give me those trucks. Does that make sense? Okay, I'm a licensed dealership. That means I go and purchase those trucks basically at cost, if not just a little bit higher than that, from Ford. Okay, so when I see a $45,000 sticker tag on a truck out of Ford, Reineke doesn't have $45,000 wrapped up into that truck. Okay, they might have $30,000 in that truck. Okay, and then they mark it up to $45,000 because they want to make a $15,000 profit. Does that make sense? Okay, so that's the idea of a markup. Not everybody does that. Okay, pretty much every restaurant that you know of, in some capacity, orders their food from Gordon Food Services or someone like Gordon Food Services. Okay, maybe like Nash Fence or something like that. That's a common one that gets used. But Gordon Foods actually has like a store you can go into, right? So if does anybody work at a restaurant? Have you worked at a restaurant before? Where?
Well, actually, it's not really a restaurant. I mean, it's walking.
Okay, so I'm just trying to give an example. Like Applebee's, I know at one point they solely purchased their stuff from Gordon Food Service.
That's when they were good.
Okay, it was when they were good. Okay, so you could go to Applebee's and buy an entree for maybe $19.99, but if you were to go to you go to Gordon's, you might only have like $7 wrapped up in the ingredients to make that entree, but they mark it up so that they can make a profit. Does that make sense? Okay. So we want to talk about what is that percent increase that they have to apply to those goods. Okay. Yes.
They have appetizers, like half off before 6 and after 10. What's that have to do with it?
Nothing. Absolutely nothing. Well, thanks. Good marketer. Okay, so the next part says you recognize this in scientific settings. Okay. In labs, okay, if you were to conduct some lab where you're taking measurements, okay, when you take a measurement as a human or with instruments, those instruments are only so precise, okay. The last class I kind of discussed the idea if I was to maybe measure all of your guys' height, okay, if I was going to measure your height and find the average of your height, okay, but I used this ruler or this yardstick where maybe it's got 1 foot, 2 feet, and 3 feet measurements. Okay? If that's they're a really good job marking them. But let's say that it only goes to 3 feet. Okay? So I measure your height. Okay?
Me.
Well, this would fit for you. 3 feet. I'm only going to be accurate to the nearest foot. Does it make sense? So if somebody was measured like right there, I'm only accurate to saying that they're 2 feet. I have to kind of guess where they're at in here, right? Now what we like to do then is we say, well, let's go 2.5 feet. So now I got a better estimation. Somebody comes here, and now I say, well, they're closer to 2.5 feet than they were to 2 feet. Okay? But then what do? They start adding more, right? Okay? And when you're in science, they talk about how this is kind of like what we call a graduated ruler, which means it has more markings on it, right? Okay. You talked about graduated cylinders before, correct? Okay. A cylinder is just like a cup, but when I put markings on it, we now call it a graduated cylinder, so I can talk about what the volume of the liquid that's in that cup. Okay. In lab reports, okay, we're using devices that might not be all that precise. Okay, so what we want to be able to do is determine, okay, this is what we measured or this is what we estimated, and this is what we know by fact by scientific fact, mathematical fact that we should be getting. Okay? And then you can talk about what the error is, we call it the percent error, between your measurements and what actually should be happening. Does that make sense? Okay? You guys ever, like if you read like right now, they keep coming out with different polls for President Trump versus any one of the Democratic candidates that's running for office. And they'll keep coming back with, maybe they say Elizabeth Warren is at 49% approval rate, or she'll, then they're using these things to say that she's going to win the presidency, okay? But at the bottom of those polls, it will say plus or minus some margin of error. So when they say 49%, when they say plus or minus then 3% at the bottom, that means that their estimation, their 49%, is actually the midpoint of what their best estimate would be as 46% to 52%. Does that make sense? That plus or minus gives us our percent error, okay? Those are things that you talk about in science. With polls, it's a huge concept in statistics classes. But this will be something, guys, that depending on the math that you take, you'll see again, but definitely see this in your science classes, okay? So percent change has two directions it can go. It can be an increase or it can be a decrease. If your new amount is greater than the original one you started with, it's a percent increase, which means it's kind of like a markup, okay? If it's a percent decrease, the new amount is lesser than the original amount, okay? When we talk about percent decrease, and you're going to see it down here in a minute, okay, down here it says if your result is negative, it is a percent decrease. If your result is positive, it's a percent increase, okay? However, both of them are going to be discussed using a positive number. We'll go through the algebra. We'll get a negative result. If we get a negative result, we take away the negative, and we add the word decrease. Does that make sense? If it's a positive result, we kind of do the same thing. We take away the positive sign, but it really probably wasn't even written there to begin with, and then we add the word increase. Okay, so increase and decrease are still viewed kind of without a sign, okay? And we add the word increase or decrease to the end to tell which direction we're going, okay? We'll do percent change, okay? So percent change is the amount of increase or decrease divided by the original amount, and then we're going to multiply that by 100 to get a percentage, okay? So I don't like that numerator, and this is the way pretty much every textbook is going to write it. It's probably the way that you've seen it already in the past in other courses. I think people struggle with that, okay? Because that in itself is a separate formula. It's new minus original. Your new value minus your original value. And you're going to divide it in by your original value. What's nice about this is that those two values are the same thing, right? Okay? If we can recognize that, this should be an easy thing to do. Then we're going to multiply that by 100. Yes?
What?
Oh, I thought you had your hand up.
I said 1.
Oh.
So you said that they're the same.
Well, so that's, if I did that, that would not be 1.
Well,
Because I got the new minus original up top. So they can't cancel like that to 1. Because it'd be like, so if I took,
oh, because you didn't highlight the
like if I took 3 minus 4 over 4, that's not going to give me 3 minus 2, or 3 minus 1, which is 2. That's going to give me negative 1/4, right? So you can't just cancel those two things. Yes? I don't know. All right, so here we got some examples. So the coat is on sale. The original price of the coat is $82. The sale price is $73.80. Wants to know what is the discount expressed as a percent change. So we're trying to figure out what percent they would have, like on the coupon or on the price tag, that would present us with that $73.80. Yep. Okay, good. So this is the formula-wise, this is the new value minus the original, which the original was kind of the old price, right? You might hear me say new minus old divided by old. And that's the same thing as new minus original divided by original. Okay, so if I do that, okay, that's going to change that to negative 0.1. Okay, now as a percent then, that turns into, so if I multiply this by 100%, 10%. It's negative 10%. Okay, so the negative tells me it's a what? Increase or decrease? Decrease. So what we do is we take that negative off and we just say we have a 10% and now add the word decrease. And that would be my answer. Okay? So here's my question. If it's a 10% decrease, and this is how I'm going to check my work here. If this is a 10% decrease of the original price, what percent of the original price are you actually paying?
90.
Paying 90%. Okay? So if it's a 10% decrease of the original price, then I'm paying 90% of the original price. Well, let's see if that works out. If I have 90% of the original price, so 90% would be 0.90, right?
Yeah.
Of means multiply. Original price was 82. Does that give me the 73.80 that's been marked down to?
No.
Yes, it does. Okay. The one thing I would be cautious of, guys, if you're using like TI-83 or 84, and I think I'm seeing some of this on your quizzes. We're doing everything we need to do by hand right. Okay? And we get to the point where we've got to use our calculator, and we go 73.8 minus 82, and we divide it by 82. Okay? Now help me out. What do I need to do first? Order of operations. Do I do the multiplication and division first, and then the adding and subtracting, or add, subtract, and then multiplication? I need multiplication, division first. So up there, the division would be 82 divided by 82, right? Well, what's 82 divided by 82? 1. So then I replace that with 1. I get 73.8 minus 1, which gives me 72.8. That's not the same number we just got when we got negative 0.1, right? Does that make sense to everybody? So put the thing in parentheses. So put the top, so wherever you're doing the, remember the fraction bar acts as a grouping symbol. Okay, so I want to group those and then divide by 82. And there you see the negative 0.1 that we get. Okay? Just going through some of our answers for some of the stuff that we've already taken quizzes on and stuff like that, I can kind of reverse engineer your answers and see some of us are making mistakes like that. We've got the right things. We got 73.8 minus 82 over 82. Then we grab our calculator to get the calculator to do that math for us quickly. We're not certain how the calculator works, therefore we get the wrong answer. Okay? Now here's the thing. I know some of you are reluctant to do this, and it's fine. I'm the same way. If I've got I'm built into my ways, and if somebody's trying to convince me to do it a different way, I'm reluctant to that. And I understand that's human nature. Okay? However, that issue does not occur when I use this calculator. When I go 73.8 minus 82, and I hit divide, I don't want that, right? I don't want the 82 underneath that 80. That's not how I wrote it by hand. That's not what my paper says when I wrote it by hand. I want that. So you see how it adds it in with that math type, okay, the math print, the way I think I should have it. Does that make sense? I think that's a little bit easier to see that, yes, that's what I want. That's the order of operations that I want done in comparison to seeing it this way. Okay? This is a safe, very safe calculator to use for this stuff. So 10% decrease. Is that all right, everybody? Okay. Now the check of that is to understand what we talked about in 2.9 with, okay? 10% decrease of $82, or we think about it as 90% of, and what I'm paying is 90% of $82. Because if it was decreased 10%, then I'm paying actually 90% of what the original price was. If it was decreased 20%, then I'm only paying, so it's the discount price, right? So when let's play off that a little bit. If I'm going to a store and I want to buy a pair of shoes, how much do shoes cost?
$35.
What?
$65.
All right, let's make it an even. Let's make it easy. Let's go 120.
No.
Kind of like an average of what you guys are saying. So let's say I got a $120 pair of shoes. Okay. But let's say that I'm going to have a discount.
Okay.
Let's go 30%. 20% is fine. 20%. Okay, so discount of 20%. So a lot of people are going to do to figure out what they're paying is that they're going to multiply this by 0.20. Okay. Now here's something that I think is very important. Where's the decimal place right here? At the 0, right? If I move that direction, that would be dividing by 10, right? If I move that direction, is that multiplying by 10? So would you guys agree that 12 times 2 is the same thing as 120 times 0.2? Okay, there's a trade-off there with the moving of the decimal, right? Would you guys rather multiply 12 by 2 or 120 by 0.2? 12 by 2, 24, right?
Yeah.
Took your calculator, multiplied that out, you get 24. Okay, here's my question. What do you do next? What does the person do next when they're doing this process?
24 minus, 120 minus.
120 minus 24, and that's going to give you $96, right? Okay. How many calculations did you have to go through? You multiplied, then you subtracted, right? Okay. Now, what we go through here is going to be still two operations, but this is easier. If you had a 20% discount, okay, you ended up paying $96. How much of this $120 did I really pay for?
Oh, I know, this is 96 minus 2.
Nope. Start back over. If I start with $120 and I had a 20% discount, that means you don't have to pay 20% of that 120. So how much do you have to pay? 80%, which is 96 as a numerical amount. But if I have $120 and I got 20% discount, then I'm only, percentage-wise, I'm only going to pay 80% of that, right? So here's the idea. Why do 0.2, 120 times 0.2, get that total subtracted from 120? Why don't we just multiply by what we're actually going to pay? We're going to pay 80%. We'll move that decimal that direction, that one that direction. I get 12 times 8, and that's 96 right away. Does that make sense? Okay, so, and the reason for this, the benefit of this, is if I'm in a store, and I know you're all going to say, well, I always got my phone on me, or I always got a calculator on me, or whatever. This would be much easier to do mental math-wise. If I'm in a store and there's something that's $119.98, I'm going to round that to 120. And if it's for sale for 20% off, I'm going to say, okay, what's 12 times 8 instead of what's 12 times 2? Keep that number. Now, okay, take that number, take 119.98 and subtract 24 from it. What do I get? There's a lot of stuff to keep track of right there in your head, right? If you can use this approach, it's faster. It's easier. Think about this. If you are, does anybody know what the sales tax in Ohio is?
100.
5.75. Okay? So when I go to the store, and I buy something that costs $100 on the dot, do I hand over $100? No. How much do I hand over? I hand over $105.75. Okay? Because you are paying not just 100% of the item, you're paying 5.75 of that item on top of it. So, here's my question. Okay? If let's say that we've got a $200 purchase. I go buy something that's $200 on the spot. I'm going to pay 100% of that, right? So I'm going to pay 100% of that. 100% as a decimal will be that, right? Then they're going to add to that amount, right? Does this make sense to everybody? Can't I write this as 200 times 1 and write this as 200 times 0.0575? Does that make sense? Okay, do those both have 200 in them? Can I factor 200 out of the first one, leave me with just 1? Factor 200 out of the second one, leave me 0.0575. Is that the reverse of the distributive property? If I distribute this, does it give me that line right there? So when I take 200, multiply it by 1.0575, that is going to give me the amount that I pay at the end. Instead of doing 2 calculations, multiply by that, and it's going to give me my total price. Okay, does that make sense, everybody? So what's that turn out to be like? 211 point what? 0.5. 211.5. Okay. So you're like your cash registers. Anybody ever work as a cashier or anything like that? So your cash registers actually have some programming in them that does that for them. Okay. And it does it that way. Okay. That's the programming in those machines. All right. Let's do one more question. It says a store buys an electric guitar for $295. Okay. The store then marks up the price of the guitar to $340. So what is the markup expressed as a percent change? Okay. You guys watch commercials. You see this a lot on like automobile commercials. They'll have an MSRP statement, and then they'll have a number. Does anybody know what MSRP stands for?
Nope. Music.
No. Manufacturer's suggested retail price. Okay? So the manufacturer, the people that make the item, are going to suggest a price for the retailers to sell it at. That's just a suggested price. Okay? Each individual retailer, and you've experienced this, I go to Walmart and buy something, it might be the exact same item somewhere else, might cost less or more. Does that make sense? Okay? Because Walmart is its own entity. They can make their own decisions on what they're going to sell things for. The idea is when I'm a retailer and I purchase items from, if I'm a Ford dealership and I want to purchase a car from Ford, if it costs me $30,000 to purchase it from the manufacturer, I don't want to sell it for $30,000, right? I don't want to sell it for $29,000 because I'm going to either make no money or lose money. Does that make sense to everybody? So they're going to mark it up, and that's what's going on right here. So every time you go to a store, you're purchasing things that are marked up. If you had the ability to go to the manufacturer and buy it from the manufacturer, it's going to be much cheaper, right? Okay. So here's the idea. It says a store buys an electric guitar for $295. We want to make a profit on that, so we mark it up to $340. Okay. So if I want to figure out the percent change, again, it's new minus original divided by original. And if we want to then tack on that 100%, I'll automatically change to percent for it. So new, what's the new price here? $340. What's the old price or the original price? $295. Divide then by $295. And when I then multiply that by 100%, so that numerator becomes, 45 divided by 295. You guys get 15.25%. Okay? And that's an increase, right? And we know it's an increase because that number came out to be positive. Okay? Well, how can I check this? How can I figure out that I've got this correct? What did I pay? I paid $295. I'm automatically paying $295, right? I got to pay 100% of the $295. But then this is saying I'm going to pay 15.25% extra percentage. So here's what I'm going to do. I'm going to take my Desmos and I'm going to figure out my percent change. So our percent change was 295. Oh, I guess it's 340 was the new, minus 295 divided by 295. So I got that, right? Now I'm going to add to that. A 1, and that 1 stands for 100%. Okay? So of the $295, I'm paying 115.25%. Does that make sense? If I change that 115.25% to a decimal, it's that number right there. I'm going to call that number any variable I want to. Let's just say P for percent. Okay? Well, if I take 295 times that number, P, what's it give me? It gives me the 340, gives me the new value, right? Okay? So my hope is that we understand that when they ask you the percent change, okay, and it's an increase, it is an increase on top of the 100% that you're already paying. Does that make sense? Okay? When it's a decrease, it's a decrease or a removal from the original 100% that you're paying. Okay, the next concept is the same exact thing. We just use different terms, different words, because it's for a different kind of application, different arena in which we use percent change. Okay, this is more the scientific or statistical arena that we're going to talk about. It's called relative error. Okay, relative error is basically how far off you are as a percent in finding the actual answer, the real answer. Okay, so the ratio of the absolute value of the difference of a measured or estimated value in an actual value compared to the actual value. Okay, that's kind of wordy and kind of messy, so let's just jump down to the formula here. It says relative error. We could replace the word relative error with percent error or percent change if we wrote it as a percentage. Okay? Now the numerator says we got those two vertical bars. Okay, and that just means absolute value. So it basically tells me we don't care if this is going to be an increase or decrease. We just want to care about how far off we are. Okay? So it says measured or estimated value. Measured or estimated value. So this is a value that we are going to try to determine. Okay? Have you guys ever played those like guessing game where they give you like a gumball machine full of gumballs and they ask you, guess how many gumballs are in there? You ever been part of those things? Okay. What you can figure out eventually is like your percent error, your error based off of your guesses compared to what is actually in there. Okay. What you would find out, guys, and this is something that we talk about in a stats class, is to answer that, you want to be the last person to answer that if you can see everybody else's choices. Okay. Because you see everybody else's choices, you take the average of everybody's choices, okay, and that's going to be your guess, and that's going to be the best guess. Okay, because there will be people that guess like something stupid like 3. There's going to be somebody that chooses something stupid like 800, and those are going to cancel each other out. And most people are going to kind of be pretty close, and if you take the averages of everybody that's pretty close, you're going to have a much better answer than what they have. That's the best way to kind of win those things. But you can determine what your error is, okay? And that's basing off of what the actual is and what we guessed or estimated it was, okay? And all we have to do is take the measured minus the actual divided by the actual. If you think about that, that's a very similar formula to the new minus the original divided by the original. Would you guys agree with that? Okay. So this would be kind of the new. This would be minus the original, and that would be the original. That looks good on my computer. It looks terrible up there. New minus the original over the original. It's the same formula. Okay. So here's the idea. So the cube's volume is estimated to be 8 cubic centimeters. That's our estimation. That's our estimation. We're looking at it, and we're just kind of guessing. Okay. It says when measured, each side is 2.1 centimeters. What's the percent error and the estimated volume? So if I've got this cube, You guys know how to find the volume of a cube? Okay, so that's 2.1, that's 2.1, this distance back here is 2.1, right? So there's my length, there's my width, and there's my height, right? So volume is length times width times height. If it's a cube, you might even say it's E cubed. E standing for edge, because all these edges are the same, right? So we get 2.1 to the third. And that turns out to be, I think, 9.261. 9.261. And that would be cubic centimeters. And that is based on our measurements. Let's say that we used a tool to measure these. Does anybody know the best measuring device to use to measure distance?
A meter.
Okay, so centimeters is a unit. But I'm thinking about device, like ruler, tape measure.
I said meter.
Meter. What's the best?
Tape measure.
Tape measure? Yard? What if I said laser? Okay. Lasers are the most precise instrument for us to determine distance because it's based off of how fast the laser, the light photon moves. And that's constant. We know how fast a light photon moves. Does that make sense? So when we measure things, you guys measure like track meets, okay, or the Olympics, they measure them with lasers, okay? So they'll take the athletes have to cross. They start all at the same time, right? And then as they cross the finish line, they actually breaking a laser, like a beam. Like you know how your garage door goes up and down?
Yeah.
Okay? And you cross your garage door beam at the bottom, then it stops, right? So that's kind of what is happening when a runner crosses across a finish line. And it's very quick that they break that beam and that beam comes back together and completes its kind of circuit, and it will stop the stopwatch, okay? But what's happening is it's actually determining distance, okay? So lasers, like we measure the distance from here to the moon, okay? We didn't take a tape measure from here to the moon, right? Okay? We use lasers and that technology to do those things. So let's say if that's what we use to measure this cube, okay? So when we do the percent error, okay, percent error is the estimated, well, we estimated it to be 8, minus the actual, which is 9.261, and we divide that by the actual, which is 9.261. If I want to change that to a percent, I'll multiply by 100. But then if we do that, 8 minus 9.261 divided by 9.261, and then multiply that by 100, and then take the absolute value. So the absolute value of that numerator is just going to make it a positive 13.
Times 100.
Okay. Times 100 because I want to change to a percentage. So I got 13.6. So the relative error, percent error here is 13.6%. Okay, which means that in the whole grand scheme of things, I'm pretty far off. Does that make sense? 13% error is a pretty big deal. If you look at the 8 that we estimated and the 9.26 that we got as an actual volume, that's quite a bit of a difference. Okay, in a science experiment, you want your percent error to be as limited as possible, as small as possible. Okay, because what happens, the reason error shows up in a science experiment is human error and error of the devices that you use. Okay, the measuring tools that you use. If we can minimize those, then our answer is going to be much more dependable and reliable. Okay. Here's another one, just kind of a basic one. It says you estimate a tree to be 45 feet tall. You actually measure it, okay, to be 52 feet tall. What's the percent error? Okay. So percent error, again, remember, is the estimated minus the actual divided by the actual. So what did we estimate? 45. Minus the actual and divide by the actual. And if I change it to a percent by multiplying by 100, so the absolute value, guys, isn't a big deal. Just as long as we know our answer should be positive, that's all it does. So if I put the absolute value symbols in and then divide by 52 and multiply it by 100, so you give me that 13.46. So I was off by 13.46%, okay, which is a big deal. Okay, it's a big amount. You guys will, at some point in your scientific careers in high school, you will do a lab where you're taking measurements, okay? And there will be a known actual fact of what you're supposed to get back, okay? It'll be like a scientific fact. It'll be expressed in a theorem somewhere, okay? And you might get something back very close to that, but not the same. And they will ask you then, okay, find the percent error. And this is exactly what you do. You take what you found, subtract from it what is supposed to be found, divide by what is supposed to be found, and then multiply it by 100%. Okay? And the hope is that you can minimize that error. If your error is like 0.01%, that means that you did very good work. Okay? If your error is very large, it means you're a sloppy scientist. Does that make sense? Okay? So those are kind of things that you'll talk about in a science class. But the idea is when you get to science, they're not going to explain that. They're not going to tell you in your lab report the last thing you need to write is your percent error. It's going to say that. They're going to tell you you have to write percent error, but they're not going to tell you how to find it. Because you learn that in algebra. Yes? 13.46. There's an assignment in Math Excel. It's like 10 questions. It's nothing tedious. It's like those questions right there. Okay, 10. Also be working on that review. Okay, I'm not going to give you homework tomorrow. Okay, and I'm not going to give you homework Wednesday because I want you to be working on those reviews. Okay, so maybe chunk it up, do half of them tonight, half of them tomorrow, half of them, third of them tonight, third of them tomorrow, third Wednesday, that kind of thing. Yes.
Actually, tomorrow I leave at 12:40. So is that right before your class starts? Yeah.
I'll record class and get it posted, but we're just going to do examples of this stuff. Okay. All right. My plan is just to go over a handful more of these questions and then start.